We're continuing our tour of the water cycle. Woo! So this point in the water cycle, we're at the tippy top of the mountains here at the glaciers. Ta-da! This is the cryosphere, so we're not going to talk too much about permafrost and tundra, but you could consider that also a part of the cryosphere. We're talking about glaciers. Glaciers are places where the glaciers are going to occur in places where the snowpack does not melt year to year. It accumulates. Then over time, it becomes a moving mass of ice moving under gravity. Okay, there it is. Glaciers. The work of ice. Today, 10% of the land area of Earth is covered by ice. Most of that is in Antarctica, Greenland, and the Arctic. Those are our places where we have big masses of ice. We also have alpine glaciers in mountainous regions, high altitude glaciers, and we'll talk about those too. Only 20,000 years ago, 20% of the Earth was covered in ice, and that is the max of the last ice age. We study glaciers, glaciologists study glaciers. They have in them lots and lots of information about past climate. We can look at air bubbles, we can look at dust layers, isotopes in the frozen into the ice. We look at this by Causey, hush. We look at this by coring our glacial ice caps, literally taking a tube and going down into the glacier, pulling a tube of ice back out, and studying the air bubbles or the dust particles in that core. We can also look at the volcanic ash layers. When volcanoes spew their ash into the atmosphere, it gets blown around the world. And glaciers, the ash is going to fall onto the surface of the glacier. Snow goes on top of that. And those ash layers are preserved over time. Glaciers also, because of their immense power of erosion and then deposition of sediment, leave behind a geologic history of that area with respect to the climate. So glaciers, by definition, are these big ice masses that move. That's the main thing you got to remember. Ice that moves. And they're moving on their own weight. We can think of glaciers as being a rock. And that rock consists of ice, crystallized water. There's air bubbles. And there also can be wet regions and rock debris that it's picked up along the way as it is eroding a valley. Glaciers are going to form on land when the winter snowfall exceeds the summer melting. All right, so I've mentioned Antarctica and Greenland. Those are big ice caps or ice sheets. There's also high altitude glaciers. So in this image, notice that at the top, the polar regions, there are glaciers from 0 to 600 meters or 2,000 feet. As we go higher in altitude, in the Alps, there are glaciers at 2,800 meters. At 30 degrees, we can have glaciers from 3,300 to 16,000 feet. And then even at or near the equator with Kilimanjaro, there is a glacier at 16,500 feet. That's because of the atmospheric cooling that happens as you get higher up into the mountains. So high altitude glaciers are because of atmospheric cooling, because of the elevation. High latitude polar glaciers are occurring because of the low angle that the sun rays hit the earth. As glaciers evolve over time, they're going to be more and more compact. So at the top of this column, we have snow. Snow is 90% air, right? Big fluffy pile of snow. Pack it down, you can make a snowball. You maybe have granular ice that is 50% air and starts to lose that beautiful snowflake shape. Firn is going to only have 20 to 30% air And then glacial ice has 20% air bubbles, so that you never really get down to 0% porosity till deep into a glacier. Okay, this is the process of turning snow into ice. It's caused by compaction, and the time frame varies from tens to thousands of years for getting that fluffy snow down to hard interlocking glacial ice with zero porosity. This is what a thin section or microscope slide of a glacier looks like. The little bits on here that look like little craters, those are air bubbles. All right, so I mentioned that there are two kinds of glaciers. We're either going to have glaciers that cover whole continents like Greenland and Antarctica. Those are the ice sheets. Or we have glaciers at high altitude that form in valleys. So this image at the top is a valley glacier. There's the glacier in the valley. They're moving downhill, usually in a valley. So they're often called valley glaciers, and they form a U-shaped valley as they erode the sides and the bottom of the valley floor. This is Greenland. It's a large, thick expanse of ice that covers the whole continent. You can imagine it's thickest in the middle and flows out towards the coastlines at the edges of it. Here is Greenland, and over the middle of it is a cross section here from A to B. At A, here we are down at sea level, and then there's a hump of mountains, and then the country has a big valley running down the middle of it, and then mountains on the other side, and this large ice cap that's pushing down the continent on the middle, that's thick here in the middle of Greenland, so almost right along the line of this yellow 3,000 meter elevation. So here's a couple links. This one shows glaciers of Greenland, and then if you have time, I recommend checking out the largest recorded calving event ever. Yeah, go check that out.